I'm going to be presenting work today that I've done with my coworkers at UC San Diego on the challenges of evolving technical courses at scale. When we think about teaching, what comes to my mind most of the time is someone standing in front of a class and giving a lecture. But for those of us who have taught classes before, we know that giving lectures is just the tip of the iceberg. There's a lot of stuff that goes into teaching. Um, there's a lot of materials that teachers use when they present their courses, like lecture slides. Some people use code. Other people have discussion worksheets and PDFs. And managing these materials involves working with a lot of different files that are put together by course infrastructures that are built together using a bunch of custom built scripts, code, and third-party tools. So now, instructors who teach large technical courses not only have to think about how to teach well, but they also have to manage hundreds of software files, configure their autograders, and debug their assignments. Past work looks at pieces of this iceberg. So for instance, at the top level, we have work that looks at problem recommendation, and there are also a set of work that looks at autograding infrastructure. We want to look at this entire iceberg, and when the question came up for us, what logistical challenges do instructors face when maintaining and updating large technical courses? These challenges are not directly related to teaching. They're incidental complexity that comes up because we have to manage big classes with lots of infrastructure. I'll present 4 case studies from our personal experiences teaching and building a data science course that highlight 4 main challenges that we see when it comes to evolving our courses at scale. When taken together, these challenges suggest opportunities for new tools to help instructors. Me and my co-authors teach at UC San Diego. At UC San Diego, we're responsible for building the data science major there, the undergraduate data science major. So we were responsible for building 8 large courses, including all 6 of the required lower division courses for the school. These courses include topics like an introduction to data science theory, and a capstone project. These courses range between 150 to 550 students. Um, we hire about 6 to 16 course staff per class, and all of these courses are relatively well established. So we've taught these courses for more than 10 times each, most of them, and they're all used in the current major, and they serve hundreds of students every year. These courses and our major has essentially doubled in size for the past 5 years when we launched it. So we've grown from less than 100 students in the major to hundreds of students that graduate from the major every year. I'm going to present 4 case studies from our teaching experiences from UC San Diego. So the usual limitations of a case study apply. I'm not going to say that all schools everywhere encounter the same problems that we do, but we chose to report problems that we found come up repeatedly for us as we teach, and that we observe other people experience in their teaching experiences. These 4 challenges are intricate dependencies between course materials. We need to manage consistent variants of these course materials. We build ad hoc infrastructure, and it's hard for us to easily reuse third-party software. I'll present a case study for each of these challenges. The first challenge is intricate dependencies between course materials. Courses have a lot of types of course materials. So for instance, a lecture might have lecture slides and a resulting lecture video. Discussions have worksheets, labs have code, and homeworks also have code. And one challenge that we face is that each of these materials depends on each other. So the discussion and lab are supposed to reinforce lecture, and the homework is supposed to reinforce discussion and lab. Between weeks of a course, we also have pedagogical dependencies. So what we when we teach in week 2 influences what we teach in weeks 3 and 4. So the material is dependent on each other not only within a week of a course, but also between weeks of a course. We experienced this firsthand when we needed to change and substitute a course topic for one of our intro courses. Our Introduction to Data Science course, the first half of it is programming in Python, and the second half of it used to be machine learning and prediction. But a few years into teaching, we decided to swap out the entire second half of the course to hypothesis testing. We did this because a course down the road, about 2 years, a course that we launched about a year or two after our intro course, eventually came up to us and said, hey, our students are really struggling with hypothesis testing. Can you help us out? And so we went back to the intro course and changed and made this change. This change required swapping out all the lectures for the second half of the course. So we had to change the lecture material and the lecture topics. And that in turn cascaded changes down to the other parts of the course. So we had to update discussion materials, we just update our labs, we had to update our homeworks and our exams as well. Moreover, all of these pedagogical dependencies are manually checked. So we had to either go through the materials ourselves or have a core staff member go through and manually look at each material. This took a lot of time and it was pretty error prone. So this is our first challenge. Our second challenge was managing consistent variants of course materials. Even a single piece of course content can have many variants. For instance, a homework assignment has an instructor version with solutions. When we give that version to students, we need to take out the solutions. When students submit their files, we have hundreds or even thousands of individual student submission files that we need to manage and make sure get put into the right autograder, get assigned to the right grading staff, and finally collect the grades together for the single grade book that we have for the class. Managing all these files is difficult. As we saw when in one of our classes, we had a text assignment, and 1 year or 1 quarter, we realized that some students are running into an issue that only happened on their laptops. And we found out that this happened because our course had upgraded to Python 3.7, but some students were still running Python 3.6. And in Python 3.7, there's a really small backwards incompatible change to the regular expression library that meant that the code that worked on their laptops broke on our autograders, which also ran Python 3.7. So this challenge illustrates not only the difficulties of managing all the different files that we have, but also different computing environments that we run the files in. Our third challenge is needing to write ad hoc infrastructure to manage scale. Because we don't want to manually grade hundreds of student submissions, we had to write our own software infrastructure to manage scale, even though our full-time jobs are teaching and instructing. So for instance, in the homework pipeline that I showed a few slides ago, we have custom scripts to pull out the solutions from assignments. We have cloud infrastructure to grade student submissions. We have more custom scripts to send assignments to the autograder and assign grading staff and to collect the grades together. This software requires maintenance and updating pretty much every time that we teach. For instance, we have a theory course where we teach algorithms, and this course started off giving students LaTeX PDFs. So we gave them a PDF, we asked for a PDF back. And to generate the student LaTeX starter code, we had a script that just hid the answers from the student starter code. After a few quarters of teaching this class, we realized we had a problem bank. So we had a problem bank of all the different homework questions that we had from previous quarters. And so we wanted to have a script that would pull problems for every quarter. So in this particular quarter, I could say, pull one problem from spring 2020 and pull another problem from fall of 2021. The script eventually grew because we then wanted to include programming questions on the assignments. So what started off as a simple set of LaTeX macros grew into a Python script, which grew into a makefile that incorporated multiple Python scripts together. These scripts solve a lot of useful problems for us, but they require constant maintenance, and whenever a bug comes up, we're on the hook for fixing it. Our first challenge is difficulties that we encounter in reusing third-party software. So a question that we get asked often is, why don't we just use off-the-shelf software? There's already stuff built out there. Why can't we just reuse what's already built? And the thing is that we try to use software. So we have tools like Canvas and Moodle for managing our course web pages. We use software tools like Git and Make and Python. And we have software tools that are specifically built for educational use, like Gradescope and a tool called Autograder. But even using tools built by third parties, specifically designed for educational use, can have some challenges as well. I'll share one story about a tool that we used from Berkeley called Autograder. What this tool does for us is it takes Jupyter notebooks and strips out the solutions and configures our autograder. So what we do as instructors is we add some special markup to our code files. We run the tool, and the tool auto-generates the student copy of our code. The challenge comes in when this tool itself updates, sometimes it breaks our infrastructure. So in one notable case, the tool had a really major bug fix that reduced the build time of our student code from 45 minutes to under a few seconds. And so when we updated this bug fix, we thought it would be just a simple oh, you update the software package and you rerun everything and it should be good. But when we did so, all of our infrastructure broke because we were dependent on some odd behavior of version 1 of the software. It turns out that a future version update is also going to once again break our infrastructure. So when that version comes out, we will want to use it, but we'll have to assign course staff to go back in, look at every single file that we have, and update all of the markup in order for it to be compatible with the new software. Okay, those are the 4 challenges. What do these case studies say about, at a higher level, about better tools for instructors? One of our takeaways is that instruction at scale lacks the tools that make open source software successful. So if I look at this iceberg, I see a lot of similarities to open source software. Open source software projects, for example, like the Linux kernel or the Python interpreter, they also have to manage lots of files that lots of people touch and update over long periods of time. These projects also have infrastructure and rely on third-party tools like Git, GitHub, and Make. But unlike instruction, open source software projects have a lot of useful tools that are custom built for their use case to make their lives easier. So for example, package installers, they can automatically track dependencies and make sure that all your packages are compatible with each other. Unfortunately, the tools that are good for open source projects are hard for instructors to use because they weren't designed for instructional workflows. For example, let's say I'm an instructor and I have a lecture slide, and I want to know what would happen if I delete these 2 slides from my course on pivot tables, let's say. What I would like to see as just a brainstorm idea is if a tool could tell me that, hey, if you take out pivot tables from these 2 lecture slides, you're gonna have to change these files in your course. You have to change this homework, you have to change these 2 labs. Are you sure you wanna do this? And if so, then know that these changes are things that you will have to do as an instructor. This is a sort of thing that when people build software, they have tools that do this sort of thing for them as they work on their software. But instructors don't have similar sorts of tools. At a higher level, what we would like to see is more instructor-centered tool design. So tools that take into account the workflows and needs of instructors. Instructors don't really want to record down oh, this homework depends on this lecture and this lab depends on this homework manually. Instead, we would like a way for tools to automatically do that. People who work on open source software projects also have chat rooms. They have incidental ways of getting context about what they're working on via maybe Slack messages or Git commit messages. But instructors don't have that either. And what we would like to see maybe is for a tool to automatically record useful bits of context that come up as we work. So we use 4 case studies that show 4 main challenges that we encountered when evolving our large courses at scale. Like software engineering, what we would like to see is tools that can help us do courseware engineering to help us manage the logistical complexities that come with running large courses and dealing with lots of software. The hope is that if these tools are developed, they can help instructors free up time and energy to do what matters most, teaching students. Thanks.
Hi, Sam. Thanks for the talk. I resonate with a lot of the challenges you mentioned here, and I think these are very interesting case studies. I'm curious to learn more about the specific roles and responsibilities of different stakeholders involved in the process. So you mentioned instructors. I assume there will be instructors who are like recording the videos, and there will be maybe like graduate student instructors or TAs who are doing the assignments creation and grading. And do you receive any sort of support from like learning experience designers from the university, or are there any like dedicated staff to the course?
That's a good question. There are a lot of stakeholders when it comes to running a course, and as you mentioned, there's the obvious the instructor, the person in charge of the course, their course staff of TAs. There are also other stakeholders too. Actually, what comes to my mind, for instance, is other instructors in the department who may, for example, come up to you and say, "Hey, like I really want this in the introductory course. Can you add it? Do you have time for that?" Um, at UCSD, there are also like industry stakeholders, for example, that will talk to maybe the chair of our department and say, "Hey, I really want your students to graduate and have this set of skills. Can you make that happen for us?" So I think there are a lot of different types of stakeholders, and one challenge that comes up in running a course is making sure the course staff knows what's going on. So oftentimes the TAs that we hire are only there for a year or two before they graduate. And it's difficult to document or have documented all the changes. So a lot of the knowledge of running a course is passed down orally. Um, so I'm not sure if this answers your question, but something I would like to see is some sort of way to automatically generate some sort of like workflow or some documentation so that teachers don't have to spend time managing yet another piece of course material that needs updating and maintenance.
Yeah, so I was thinking more of like as we are talking about these as challenges of the instructors, whether these are more challenges of like graders or TAs, and whether there are any like collaborative patterns between these different stakeholders in this process.
Yeah. So I think the problems the problems at a top level, I think the instructors are responsible for. So if the course goes up in flames, most of the blame will go to the instructor and not to the TA. But ultimately, the instructor does. We do try to distribute work to the course staff to try to make the load manageable for ourselves. Um, but I think at the end of the day, it is a lot of. At the end of the day, I would say the instructors are on the hook for most of what happens in a course, at least in our experience.
Hey Sam, we've been in the Jupyter Hub trenches together, so I can resonate with a lot of these challenges. But I was wondering also from a perspective of having worked on open source for a few years, I think the big difference is that in open source, you're always designing for generalizability. And for these instructor workflows, you're continually designing for fixing the biggest crisis because you have humans depending on the solution coming out for an assignment that you're introducing tomorrow. And I think that is the big difference in these workflows. And I was wondering if you found a way to motivate. I think the reason open source software works so well is because that is at every step of the pipeline. There's so much peer review and code review, and it's not necessarily so rushed all the time. There are like CI/CD workflows and lots of ways to check that all of these things will not break so often.
Mhm.
But here we don't really have the time for that usually as instructors panicking, I guess. So how would you integrate that part into this workflow, or is it just something our community needs to work on?
Yeah, I would say that's one of the main assumptions that our like software tools make of us that doesn't really match our own personal experiences. So a lot of the software tools that we use assume that we are these really hardworking software engineers that really want to make the world a better place with our code. But I think in reality, most of the time as an instructor, we're just like, I have a lecture tomorrow. Like, what do I do? Um, I think in terms of research, the research areas that I think resonate with this sort of mentality is the research area of end user programming. So programming as a means to an end, as opposed to programming as the end product. And I think um, for us, the vision that we see is a set of instructional tools that are designed with that in mind. So not designed for people who are like full-time software developers, but are designed for people who have these more like goal-oriented. I need to get this job done. I don't really have time to document. I don't really have time to make everything nice. I just need to get it done. Can you help me out?
All of it resonates not just for teachers, but for developers. I remember being a TA actually, and my task was to walk students through installing Tomcat and Java and make them work together. So it's great that that CI/CD was mentioned. So to add to initial students, worries, install Python, spend more time making sure that you set up virtual environment, right? Set the package versions once and for all for this semester, right? So it's slightly more trouble in the beginning for the students and for professor, right? You cannot just, I have a lecture tomorrow. That wouldn't work, right? But spend more time in the beginning. And in terms of workflow, I think containerization worked pretty well. You don't have to install Python, just pull a container, throw your file in there, or student file 1,000 times, right? If there are 1,000 students. So that, again, a little more buy-in in the beginning, but there's plenty of examples. Googling helps. I didn't know anything about containers. I didn't know anything about VMs. And if something doesn't work, downgrade your Python version. That's just a universal hint. Literally, like 2 weeks ago, something wasn't working. Python 3.8 to Python 3.7. Magic.
Yeah, and for us, like we just think it's crazy that that's the advice that we get, right? Like we're just like, why is the advice downgrade my Python version? Um, to more directly address your comment, I think we do have some workflows that can help for more introductory classes. So for our Intro to Python course, we're using like we have like a cloud environment set up so students don't visit a website to write code instead of having to install software on a computer. And that helps a lot for introductory courses. But for more advanced courses, especially for cases like data science, where a lot of students are imagining themselves going into industry and installing software on their own computers, we did want to like we do want students to experience something that's realistic to what they'll experience when they go on the job or perhaps go into research as well. So there's a trade-off here between in terms of infrastructure and making life easier for students versus giving them a realistic experience of having to debug their environment and doing all of that. So it's an interesting trade-off and one that we've had to consider while teaching.
Okay, we have two questions, and I think since we'll go with Kristen first, and then Michael will get the last question because then Michael's presenting right after.
All right, thank you. So the first thing I want to say is just I feel these challenges in my bones. Like I also teach large classes, and I definitely feel this. I have kind of more of a comment, and then I have my questions. My comment is that one way that I am from Duke University, and so one way we've tried to address this is that we have hired teaching support staff that are attached to a course. And so regardless of the professor, they are there kind of holding the knowledge across course offerings, and that has helped immensely in some of these aspects. The question I have is, as I teach my large classes, I'm also slowly building like more complexity and more scripts and more things into my class. And do you have any advice on trying to mitigate these challenges as much as possible?
Oh man, I didn't come prepared with advice. I just came with a list of problems.
But you thought about it longer than us.
Well, I think I think the thing you mentioned about continuity helps a lot. So
Mhm.
having if the environment, like the staffing environment allows, having TAs or other maybe like third party like auxiliary instructional staff that can stay on a course from year to year is very very helpful, and very very helpful because it's I think like a lot of the knowledge about a course, it's most important for it to retain in people's mind as opposed to being written down somewhere. So it doesn't matter if it's written down somewhere well if no one reads that documentation or understands it. Um, so honestly, I think from our experiences, the most helpful thing that we've done is just to acknowledge the fact that, oh, okay, like there is a lot of infrastructure and logistics that goes into running a course. We can't just drop people in and have them learn on the job. We do give them we do try to give them a little bit of um, training and support, and just acknowledging the fact that um, oh yeah, there is a big like hurdle to get across when it comes to running a course logistically, has helped us a lot because it's helped us to mentally allocate time aside to train people not just on teaching but also managing and running a course.
Mhm. Right, thank you.
Great, thank you. Okay, we'll transition into Michael, and Michael, you can ask your question and then get ready for your presentation.
Sure. Thank you. I guess just quickly, thanks a lot for this presentation, and it certainly resonates as well with me. Do you think all of this has an impact on outcomes for students? Like, is this actually driving quality of instruction and teaching like down, or is it like just a headache and a suboptimal use of time?
That's a really good question that I'm not certain what the answer is for us. I don't have any particular measures that I can tell you about, oh, with this many problems in the course, um, this like it caused like this decrease in performance. Um, Anecdotally, I can say from our course evaluations that students do notice quite a bit when there are inconsistencies with the homework. So whenever there's a whenever there's like an autograder test that isn't right, we have a lot of emails from students complaining about it, and then oftentimes they'll mention that in their course evals as maybe comments like, "This course like taught good concepts, um, but I really wish it could have been run better because I spent a lot of time like banging my head against the wall because I thought my code was wrong when it was really your autograder that was wrong."
Mm. Okay, thank you. Yeah, that's interesting.
Okay, so Michael, as you switch over and get ready for your presentation, I'm just going to pass the mic here for a quick pitch.
Yeah. So there's a tremendous research agenda in everything that you're talking about. It seems to me. So I would make a pitch that you guys ought to look at that mid-scale research infrastructure conferences idea that I mentioned yesterday. Let's see, the target date for proposals is July 1st. That's a month from now. I just think that there is enough interest here that you ought to get the people, not just in this room, but around the country, perhaps around the world, that are interested in exactly this sort of thing. It just seems to me, I mean, it's a glimmer of something. It's a little half-baked in my own head, but I think you ought to really look into that.
Thank you. Can you say that name one more time for me?
Yeah, well, so there's this Renee. I think I sent you the information about it, but it's a new opportunity. We just released a Dear Colleague letter at NSF on mid-scale research infrastructure incubators and conferences. The incubators are a larger sort of thing. You might be interested in that too, but even just getting people together to really explore this notion of this kind of infrastructure, which then can supports there's a lot of research about what's happening in these large classes. So
Thanks.
Thank you. Thank you so much, Sam.
Thank you.